In this last composition of functions video, we're going to look at finding compositions of functions, but then also stating what the domain of that composition of functions is. So we're going to start here with example 6, and it asks us to find f of g of x and then state its domain. So as far as the algebra of this is concerned, finding f of g of x shouldn't be too tricky for us because we can see that f is just simply x squared plus 5. And so I'm replacing wherever I see an x with g of x. And then I have g of x squared plus 5. But then, of course, g of x, we know, is the square root of x. So we end up just taking the square root of x squared plus 5. And so that simplifies to x plus 5. So we could say a simplified version of f of g of x is x plus 5. Now, of course, if I look at this function here and just taking it at face value, if I was asked what the domain of that function is, I would say that the domain would just simply be negative infinity to infinity, right? Because I'm not going to divide by 0. There's no variable in the denominator. And at least at face value, I'm not going to take the square root of a negative, right? So those two things that we check for when we're finding the domain don't seem to appear. But if we take a look, let's take a look at our graphing calculator here. And let's go ahead and type in these two functions. So first of all, x squared plus 5 and the square root of x. And then what I can do if I want to look at the composition of these functions is define my y3 as y1, so alpha f4. So hit alpha f4 and then find y1 and press enter. And then in parentheses put y2. So alpha f4 y2. And you can see the function notation working here. So I've got that composition of functions, and let's deselect the two individual. Actually, let's keep them selected. And let's go ahead and graph all three of these. Okay. So as you can see, we've got our x squared plus 5, our y equals the square root of x, and then here is x plus 5. But only the part of y equals x plus 5 that is to the right of the y-axis is showing. And so what we can see here is that the domain of the red graph is only from 0 to infinity. And it seems like the y equals x plus 5 function also is following that domain. So of course what's happening here is that even though f of g of x equals x plus 5 looks like there aren't any domain issues we need to worry about, the fact remains that when we are doing this composition of functions, we're still sending x values into g first. And the fact that it's simplified algebraically doesn't change the fact that we're still having to put values directly into the square root. And of course we know we can't put negatives into a square root. So I think a helpful thing to do here is to go back to the diagram where we say if we want to look at f of g, then what we're really doing is we're taking x's, we're sending them into g first. They're coming out as g of x. Then we're sending them into f, and they're coming out as f of g of x. So regardless of how it simplifies, we need to check this inner function, this inside function, and see if there's any domain restrictions on it. All right. So here's how we would kind of summarize that. The domain of f of g is a set of all x in the domain of g such that g of x is in the domain of f. Now that's kind of a wordy, mathy definition. And so let's look at example 7, and this will kind of help give us a way to approach this really systematically. So here we've been asked to find f of g of x and state its domain. And we're given f of x and we're given g of x. So a systematic way to approach the question of domain is to start by just stating the domain of f and g individually. And when you do, I don't even necessarily need you to put it in interval notation right away or anything like that. But for the domain of f, we can see that it's important that x minus 3 not be equal to 0, right? Because we do not want to divide by 0. So add 3 to both sides, and we get x does not equal 3. And again, don't worry about putting an interval notation or anything like that. When we look at the domain of g, we can see that there's a square root involved, and we know that we're not allowed to take square roots of negatives, so we need to make sure that x is greater than or equal to 0. Okay. Now, we want to find the domain of f of g of x. So at this stage, what's important to do is to remember our diagram of what it looks like to take f of g of x. So for f of g of x, right here, f of g of x, since g of x is the inner function, that means we're sending x values into g first. They're of course coming out of g as g of x, and then they're getting sent into f, and then they come out the other side. So based on this diagram, on the one hand, I note that it's important that x follows all the rules that g needs it to follow. In other words, we're going to use the domain of g. We're going to use the domain of that inside function. All right? So as we go for the domain of f of g of x, we first note that x is greater than or equal to 0. That's us checking the domain of the inside function. But what's also true is that we need to make sure that we don't end up sending anything into f that causes problems. So when we send things into f, though, they are coming in the form of g of x, right? Because they've already been through the first part of this diagram. They've already been through g. So the other thing we need to do is we need to look at the domain of f, and we can see that it's important that the inputs of f are not equal to 3. But since our input in the composition is now g, then we can say g does not equal 3. And of course g of x is the square root of x minus 1. So adding 1 to both sides, we get square root of x is not equal to 4. So then squaring both sides means it's important that we make sure that x is not 16. So I put this fact, checking the inner function, together with this fact, and then that forms the domain of f of g of x. So from 0 up to 16, and then we pick things up again after 16 and go to infinity. So we can see x is greater than or equal to 0, and then everything above 0 and above is okay, except for that number 16 because of what we discovered here. Okay, so keeping this diagram in mind I think is really helpful, right? Sending it into g first, so use its domain, then make sure that g of x is not causing problems with f, right? By making sure it's not equal to 3. That's just the domain part. Now let's think about the simplification itself. So f of g of x. So what I'm doing here is I'm just taking the function f and I'm plugging g of x in everywhere I see an x. So g of x divided by g of x minus 3, which is equal to g of x is the square root of x minus 1. And then on the bottom here, square root of x minus 1 minus 3. So my simplified f of g of x is the square root of x minus 1 divided by the square root of x minus 4. So there's our simplified function along with the domain of that function. But by the way, you can also see what we discovered just here in the simplified version, right? We discovered that it's important that x not be 16 because what that would eventually end up causing us to send something problematic into f. You can see that here. If you put a 16 in for x, square root of 16 is 4, then we would be dividing by 0. All right, so let's do another example here. So we have f of x and g of x. We want to find f of g of x, and we want to state the domain. Let's, just like the last problem, let's start by just noting the domain of f and the domain of g. F's pretty easy, right? We don't want to divide by 0, so no algebra to do there. We're just saying make sure that x is not 0. For the domain of g, it's important that x minus 2 not be equal to 0, which means x should not be 2. All right, so here we're doing f of g of x, so it's really the same diagram as on the last page, right? Inputs, x's, are being sent into g first. They're coming out as g of x, and then they're going into f. All right, so now let's think this through. First, we need to check for, am I sending anything into g that's problematic? Well, we've determined already that x should not be 2. Okay, so as I'm stating the domain of f of g of x, we can say x should not be 2. On the other hand, we need to make sure that g of x, okay, doesn't send something into f that's a problem. So up here we noted that x should not be 0, so since we're sending g of x into f now, we need to make sure that g of x is not equal to 0. Of course, g of x is 1 over x minus 2. And at first this equation might be a little bit confusing to you, but let's think about it this way. I just have a 1 on top. I never want to make the bottom 0, right? So the only way to make this expression be 0 would be if the top was had variables in it that I could then make the top 0. That's impossible here. And so if this was an equation, we would say it has no solution. For us, it's going to say does not give any additional restrictions. But the key here is we checked both, right? So we checked the domain of the inside function of g, x does not equal 2, and then we checked to make sure that any g of x values we get won't cause problems if we send them into f, and we didn't find any problems there. So our domain would be everything except 2. So negative infinity to 2 and 2 to infinity. And then they wanted us to find f of g of x, right? So f of g of x means I'm taking 1 over g of x instead of 1 over x, which is 1 over x minus 2, which is 1 divided by 1 over x minus 2, which means times the flip. x minus 2 over 1. So f of g of x is just simply x minus 2. And this is a good illustration of why it's so important to check the inner function, because at face value, just like our earlier example, y equals x minus 2 doesn't seem like it should have any domain restrictions. Doesn't seem like there should be any problems. But because we check the domain of the inside function, we realize, okay, it's important that x not be equal to 2. So there's our domain, and there's our simplified composition. All right, this would be a good chance to pause the video and try part B on your own. I'm assuming you've done that. Now let's work through the issues with part B. All right, so let's start with domain. This time my diagram looks different because we're doing g of f of x. All right, so f comes first. We're sending x's into f. They're coming out as f of x, and then we're sending those into g. All right, so first of all, when we're thinking about the domain, we first check the inside function. The inside function is f, and so we just use this. We need to make sure we do not let x be 0, right? Because that causes a problem right at the outset. But then, since the domain of g is that its inputs should not be 2, that must mean that our outputs for f had better not be 2. So we would also say, and f of x is not equal to 2. So I'm literally just taking this statement here and replacing x with f of x. Now f of x, that's 1 over x. And then I can go ahead and multiply by x on both sides. So I end up with 1 is not equal to 2x. So then dividing by 2 on both sides tells me that x should not be a half. So putting these two facts together, the domain should be everything except 0 and 1/2. So negative infinity to 0, 0 to 1/2, and 1/2 to 0. Or excuse me, 1/2 to infinity, excuse me. All right, and then lastly, let's actually get a simplified version for g of f of x. So we have g of f of x. So we're going to take 1 over x minus 2, and where we see an x, we're going to put f of x in there. So it'll be 1 over f of x minus 2, which is 1 over x minus 2. And I think the easiest way to simplify this is just to clear the fractions out by multiplying by x on both the top and the bottom. So this will be x on top, and then as I distribute down here, I end up with 1 minus 2x. And interesting to note here, just from the simplified version here, I can see that x should not be a half, right? Plug a half in here, you're in trouble. But you cannot see that 0 is problematic. So this again just reminds us of the other way we can approach these is if you're asked for the domain, if you want to start by simplifying your composition, then you can just try to figure out the domain of your simplified function just based at face value, and that would yield that x should not be a half. But then you just remember, oh yes, and also I have to check the domain of the inner function, right? And so then that would say, oh yeah, and also x should not be 0.